Lab 2, Magnetic Field of a Bar Magnet by Shervin Praveen. Introduction. The purpose of this lab is to calculate and then model the magnetic field of a bar magnet from different observational positions. In this experiment, we will be using GlowScript to compare our experimental results with a digital model. Main physics ideas. Biot-Savart law. The first formula gives us the magnetic field due to a current. The bar magnet magnetic fields. The first formula gives us the magnetic field from the source to an observational position, which is on axis. The second one is when the observational position is on the perpendicular axis, when mu is the magnetic dipole moment, which points from the south to the north pole. In the bar magnet, we have the distance dependence formulas and the magnetic field off axis formula, when it's not perpendicular or on axis. Experiment. To conduct the experiment, we will first use a magnetometer on our phone to measure magnetic fields. We will first angle our phone in a way so that the x-component of the magnetometer reads 0. This means we are lined up with the Earth's magnetic field. The reason we do this is so that any change in the x-component is only due to the bar magnet, since we are already lined up with Earth's field. Finally, we will be measuring different positions and distances relative to the magnet to see how the magnetic field varies. Results. The results show us what we expected. When the magnetometer is further away from the magnetic field in the x direction approaches 0. This means that as the magnetometer moves closer to the magnet, the measured x-component of the magnetic field increases. Pre-coding. Before we begin coding, we want to find the magnitude of the magnetic moment. We start with the distance dependence formula. We take the natural log of both sides, and from the graph in algebra, we find that n equals negative 2.9834, which is the slope of our graph. We find that ln of k is equal to negative 14.087, which is the y-intercept of our graph. So k equals 7.622 times 10 to the negative 7th. After some algebra with the perpendicular axis formula, we find that the magnitude of the magnetic moment is 4.8472 amperes times meters squared. Coding. In the bottom image, I set up a function for the formula for the magnetic field off axis. In the top right, I set up different arrows and positions for different observational positions around the bar magnet to model. And in the top left, I set up an observational position which is 45 degrees from the magnet at a distance d away. These are the coding results. In the images, we can see how the magnetic field varies around the bar magnet. And in the next slide, we'll talk about the different magnetic fields we get at the 45 degree away position. As we can see, the measured model resulted in a magnitude of 8.26313 times 10 to the negative 5 teslas, while our simulation measured 8.02864 times 10 to the negative 5 teslas. The possible reasons for this error could be with the magnetometer, how I measured distances, or how the electrical devices around the experiment affected the experiment. These are the possible errors. What if? What if we hadn't compensated for magnetic north? Our results would not have been as accurate unless we compensated afterwards. The reason we aligned it in the first place was so that our bar magnet measurements would start from 0 magnitude initially. What if instead of one magnet, we had 2 magnets stuck together? This would result in approximately a double magnetic field because the magnetic moment would be double. Thank you.